Okay, hi everybody. We're going to go ahead and do some combined gas law practice. Really, the combined gas law is what we've been doing all along. We've just been looking at examples where only two variables change at a time, and those, for whatever reason, have specific names like Gay-Lussac's law or Charles' law, but they all come from this combined gas law. And so when I say we're doing combined gas law practice, what it means is that we just have more than two of these things that are going to be changing at the same time. But it's exactly the same process that we've been doing. Okay, so let's look at the first problem. A 2.3 liter balloon contains 4.5 moles of gas. It's taken from Woodland Park at 15 degrees Celsius and 570 millimeters mercury to the top of Pikes Peak at negative 15 degrees Celsius and 425 millimeters mercury. How big is the balloon? All right, so I've got a gas that's changing conditions, so I know I need to use my my combined gas law. So I'm going to write that down. P1V1 over N1T1 equals P2V2 over N2T2. Notice that we've added that in to the bottom that's not on your periodic table. That stands for the number of moles in the container. All right, let's go ahead and write down our initial and final conditions from the problem. So let's do it again. A 2.3 liter balloon. Okay, so that's giving me liters is volume, so that's my initial volume. 2.3 liters. Contains 4.5 moles of gas. So N1 equals 4.5 moles. It's taken from Woodland Park at 15 degrees Celsius and 570 millimeters mercury. If it's taken from there, then those are my initial conditions too. So T1 is 15 degrees Celsius, and P1 is 570 millimeters mercury. Okay, to the top of Pikes Peak. So that's the new conditions, and so these are going to be my twos, my second final conditions. Negative 15 degrees Celsius. So T2 equals negative 15 degrees Celsius, and P2 equals 425 millimeters mercury. How big is the balloon? So it's asking me what is the new volume of the balloon, because big is volume, or big is size, which is volume. Okay, so V2 equals, we don't know. Now notice it didn't give us an N2, and so what that means is the number of moles isn't changing, and so it's the same on both sides of the equation, which means if it's the same on both sides, I can cancel it out, and so I can cross that out here. And that makes sense, right, because it's a balloon, so it's tied closed, so the number of moles of gas in that balloon is not going to grow or decrease. Okay, so that makes sense. Let's go ahead and plug these numbers in. Oh, wait, can't plug in yet. We have matching units here. These units match, but temperature must be in Kelvin. So we have to use this formula and convert our Celsius to Kelvin by adding 273.15 to it. So this is going to be 288.15 K, and this is going to be 258.15 K. All right, now we're good to go ahead and plug in. So I've got P1 times V1 over T1. So 570 times 2.3 over 288.15 equals P2V2 over T2. So 425 times V2 over T2, 258.15. Okay, there are lots of different ways to solve this, and you don't have to do it the way that I do it, but what I'm going to do is multiply 570 times 2.3 and divide it by 288.15. When I do that, I get 4.5497. I'm not worried about sig figs yet because I'm not to my final answer, and so it's good to go ahead and leave extra digits so you don't end up a little bit off on your final answer. And then on this side, I'm going to do 425 divided by 258.15, which is 1.646 times V2. Okay, now I'm going to divide by the coefficient of V2 here, 1.646, so that I can get V2 by itself, because that's what I want to know. Okay, and then this will cancel out, and I get that V2 is equal to, when I round it, let's see how many sig figs do I have to round it to. I've got 3 sig figs here, 2 sig figs here, 2 sig figs here, 3 and 2. So I get rounded to 2 sig figs. So I'm going to get 2.8 when I round that to 2 sig figs. I'm looking for volume. My unit of volume was liters, and so that is my new answer. Okay. So there is a key to the rest of these problems. I'm not going to go any further because it's the same process we've been using. I think you can do it, but feel free to check your work with the key as you go along. Thanks for watching.